Welcome to our podcast, ladies and gentlemen. Today is podcast number six, and I got the cord on me here. I am Derek, and I'm coming to you from Jewett, New York.
And I am Jay, and I'm here in Orlando, Florida.
Excellent. Today we have an awesome podcast designed for you. We're going to talk about circuit boards, and we're going to talk about circuit board assembly. So Jay, I have a product in mind, and I'm not really sure how to bring it to life, and I'm hoping you can help me. It's this type of a thing that goes on, like it's like a wearable, like a wrist device. And I'm wondering, in speaking of terms of circuit boards, what's the first thing I need to do? Like, how do I even start with a circuit board?
So typically, if you have an idea in your head, you want to come up with like a proof of concept. And the best way to do that with circuit boards is to use like a breadboard. And there are lots of companies that kind of sell different little boards like this with different sensors and different microcontrollers. And then you buy something like a breadboard and you buy like a wiring kit. And either you get familiar with all those things and put it all together and write some code, or you find someone who knows how to do that. And you can kind of build out your proof of concept and make sure it works on a breadboard.
Okay, so you take the concept. You can buy different sensors, you can buy a breadboard, you can buy these little wires and kind of connect them up. And then what you're saying is then at that point, if I wanted to, I could probably write some code on the computer and then connect the two together and then see if the proof of concept will work. Is that what I'm gathering?
Yeah, pretty much. It'll work. It should work exactly like the real product. It's just not going to look like it. It'll be on a breadboard. It'll be very delicate. It could fall apart on you very easily, so you have to be very gentle with it. But you can definitely prove the entire concept on a breadboard without having to design a circuit board.
So that's great. I have this idea of this kind of watch or this little wearable that would go around my wrist. And I've heard the term Internet of Things, IoT, but I just really, to get started, I can design this breadboard is what I'm understanding. And if I don't know how to like design a circuit board how do I design a circuit board? What's the first thing I need to do? Or what would you do to design a circuit board?
So after you have that proof of concept and it works for you and you're happy with it, the next step would be to pick a software tool like Eagle, Altium, KiCad, one of the open source ones. You basically need to pick a tool so you can start laying out your schematic. And the schematic is basically all the same components, all wired together in a diagram that kind of resemble that breadboard model that you have made. That would be the first step.
So you start with the software, and then you design a schematic using that software. And you mentioned that there's some open source. They're free. What do those softwares cost?
So the open source one I'm not that familiar with. We use Altium, which is really expensive. It's like, I don't know, like $12,000 or something like that for a license. You can also do like Eagle, which is like a subscription. KiCad, I think they have some free ones out there. Eagle used to be free before it became part of Autodesk. And I think there are lots of free ones out there. Again, I'm not familiar with all the different ones. There are plenty out there. I think just simple Google.
So you can
Google about that.
Search Google. You can look for softwares if you're going to do it yourself. You can hire a company. And if I was going to hire a company to design circuit boards, I'm asking if they have Eagle or Altium, and that's going to help me to qualify that they know what they're doing, more or less. You think that would be a good indicator?
Sure. I mean, at least it'll give you a little idea about the company. If they're using just open source free stuff, or if they're really if they've been around for a while, they're probably using Altium. It's just a more sophisticated platform. It allows you to do more complicated designs like 6-layer, 10-layer. We could talk about layers later.
Sounds good.
So
you're designing a schematic with the software, and a schematic, is it kind of just showing how the different parts interconnect and how they connect together, and just, what is a schematic?
Yeah, so schematic is exactly what you just said. It's all the parts have like this little block, and each block has a bunch of like points or nodes that you can connect to, and the schematic shows how everything is connected on the board.
Okay.
And each connection represents like a copper trace on the PCB.
Okay, so you're kind of drawing all these lines and connecting with different nodes and different items together. How do you identify what sort of materials that you would put in your schematics? How do you identify the components?
That's actually a very challenging thing to do because if you don't have experience with electronics design, you won't really know what components to pick. So you definitely want to work with someone who's done it before, who has some experience in that field. So if you pick IoT, you definitely want to have someone who knows, Wi-Fi and Bluetooth and stuff like that, so they know what components they need to pick and put together on your design.
I think that's a good point. A good takeaway or a good tip there would be if you're hiring somebody to design a wearable device and you know it's like a Bluetooth device, you should qualify them by asking, do you design Bluetooth? I guess it's kind of like everyone has their own areas they can learn how to design for that. But specifically, if they already have experience designing with that technology, it's going to make it a little bit faster and more streamlined for them. Like if they're designing RFID or Wi-Fi or LoRaWAN or Bluetooth, if they already have
Mhm.
experience, you can move that forward. Is that what I'm understanding? Yeah.
Yeah, for sure. And then
Perfect.
another thing you can do is a lot of companies make development kits. So you
Okay.
can go out and look for development kits in the different fields like Bluetooth or Wi-Fi or GPS, and you can download their development kit information. They sometimes they'll provide a schematic and drawings, and that'll kind of help you pick the right part because you're relying on their design a little bit. But again, it is definitely a little more complicated. You definitely want to work with someone that has done it before or knows how to piece these things together.
So if you're using a development kit, do they give you the schematic to use? Is that something that's available to you? So when you design the circuit board, you have that schematic to kind of follow?
Yeah, but yeah, they do, but it will be an Altium or something, right? Because all the big companies, that's what they use, and you might be using an open source or free version, so you'll have to like redraw it or figure out how to import it,
Mm.
which I don't know if you can import it. Normally, you have to redraw that schematic or that portion that you need to use, and then supplement, all the other components that you need to add to that schematic. But yeah,
So
they
early
normally
on,
do provide a nice detailed drawing about their development kit. I have some here. I can show you.
yeah, what does that look like?
So basically, a development kit would look something like this. It's very complicated looking. So there's lots of components. This one probably has hundreds of components, but this is something you can buy off the shelf. I think this one's like $30 or $40, and it allows you to develop a Bluetooth product, and you can download the schematic and the board design files for this as like a reference for when you make your own. So this will be a
So
great
you
starting point, and then you can kind of see what parts they used, right? So you can see the buttons they're using and whatever capacitors and resistors and memory, and you can kind of decide, okay, yeah, that's a good one. Let me carry that over to my design, or no, that doesn't work for me. I need to change this or that. So that's kind of how the development kit work. And again, every company makes these for different, all their different products that they sell.
Now, you mentioned early on you can design a breadboard, and now you're talking about a development kit. So to me, it seems like I would probably want to start with a development kit, if at all possible, because it seems like it's already working from the big companies like NSX or Qualcomm or some of the big chip design manufacturers. Wouldn't we want to start there and then kind of take the firmware and any sort of sample code and move that forward?
Yeah, I think it's the same thing though. I think you can start with a development
Okay.
kit or a breadboard. They're kind of in the same category. Like you want to use these off the shelf things to kind of put together what you want. So, here's another example, right? It's just like a little shield that you can buy. This one has GPS on it, and then I put a screen on it. So you can just kind of solder this stuff together. It's not just it's hacked together, and then you put it on your development board, and then you can start programming. And this only took me like an hour versus having to design this from scratch.
That's great. So how do I take something like that, a development kit, and like shrink it? I need it to be smaller.
So that's when you would basically work with someone who has schematic design experience, board design experience, and then they would take that and start removing all the stuff that you don't need and shrinking down that design. And sometimes the design, like something like this, it's single sided. So you have this whole other side. So if I started, moving all these parts from this side to this side, you can imagine I can definitely shrink this down. So once you start going more into your custom design, you can start moving things around, removing parts you don't need, and then shrink the design to what you need it to be. So you could take something like this and, and your final product would just be like that. So it's the exact same product, but I've deleted everything. It's not coming in focus. Okay, well, you get the point.
Can you talk to me about packages? Like what are the different packages available? Like you have some that have pins and some that mount on the surface. Some are bigger, some are smaller. Would that be helpful for shrinking it down as well?
Absolutely. So a lot of the beginners, they'll start with something called through hole. And so those are basically parts that go through the board. Like they actually have to go through the board and solder on the backside. Most of the stuff you buy nowadays, like nobody really uses through hole. Like for this, you can see those pins. I think you could see those pins. They go right through the board. That's called through hole. Normally a lot bigger. Can you see that?
Yes.
And then the other technology nowadays that everyone uses is called surface mount. And surface mount are all the little components that they don't go through the board. They're right on top. So they're soldered to the same side that they are sitting on, so they don't go through the board. So that's definitely going to enhance your package, right? It's going to shrink your final product size because you're using all these tiny little parts that they don't go through the board, and they come in very small sizes.
What do you think is the most challenging part with taking a development kit and shrinking it down into a smaller design?
It's just about the routing. So, you can do the schematic. Schematic is a lot easier to do because you're just connecting wires. You're not really thinking about it. But then when you go to actually lay out the board design, it is way more complicated because you actually have to route those wires. So all those wires and all the schematic, in your schematic drawing, you have to go from that part to the other part and make sure you have, it takes hours and hours and hours to route something that's very complicated. The smaller you get, the harder it becomes to route.
So what I'm learning there are some pins on the circuit board, and each one of those pins will connect to a different area on the chip, and they each serve a different function. So one, you might have power, one, you might have ground. And then what you're saying is the smaller they go, the closer they come together, and it makes it more difficult for routing. You're kind of creating a map, right? And trying to figure out.
Yeah, it's like roads. You're creating roads for the signal to pass, and sometimes the roads have to cross over each other, so you might have to build like a bridge, over the road. In PCBs they have obviously layers, so the layers allow you to build bridges and stuff.
PCB meaning printed circuit boards or circuit boards, yeah?
Correct, yeah. PCB meaning this green, printed circuit board.
All right, thanks for showing. So you're showing a green circuit board. Do they come in different colors? How do I get them in different colors?
Yeah, so when you order once you have your design done, when you place your order, you just tell them what color you want. Most PCB fabs offer, 5-6 different colors: black, white, green, yellow, red. But yeah, if you don't tell them, it'll come in green. That's the most common color.
And then can you change the text that's on there as well? The text color?
So the text normally basic, it defaults to white, but you can change it to any color you want that they offer.
And then how do I make a prototype, and how long do prototypes take to get made?
So generally, to make a prototype, what you want to do is once you have your design done, you would order the bare PCB, the green part. And there are hundreds of companies that do this for you. Depending on where you order it, if you order it in the US, you're probably going to pay hundreds of dollars. If you get them from China, at the fast, quick turnaround stuff, you can get them for $5. But then, the shipping takes a long time, so you have to wait for it to show up. And once you have the green portion, then you would order all of the parts that are needed, that are on the board. And you would also order a stencil. So again, I'm talking more about like surface mount design. Obviously for the through hole stuff, you could just solder them. So you would just put them through the board and then you would solder all the points. For the surface mount stuff, you would need a stencil. And the stencil, you would use that to apply a solder paste, like a lead-free solder paste. And then you'd have to sit with the microscope and put all the parts on, and then you'd need to bake it. And there are a couple different ways to bake it. If you have an oven, you would be able to bake it in that, or you could use a frying pan method. which we used to do back in the day. But there are quite a few ways to do that.
Excellent. And then it's a prototype. Or, why isn't it? What's the difference between a prototype and a finished product? Why would I need to do a prototype? Why don't I just make the finished product?
Well, in PCB assembly, I mean, there really isn't much of a difference because once you design it, that's your product, whether you do a prototype or production run. The only difference with production is we would put it in like this panel form instead of a one-off, so we could use the machine to do it. So we didn't have to hand make it. So this panel is of 4 pieces, and it would just go right through the machine. All the parts would get populated. It would go through an oven, and then it would be done on the other side. Then you just clean it, program it, test it. So that would be a production panel. And then if you were just doing a prototype, you'd probably get them pre-cut like this, ready to, just ready to mount by hand.
So you can get any different shape, or are there like squares and rectangles? How does that work?
Yeah, so you can get any shape because in the software, you would just draw the outline of the board. So you can put holes wherever you want. You can cut it in any shape you want. You can do all kinds of fun shapes.
Okay, and would it be fair to say a prototype is a prototype because you need to prove it out and make sure that the circuit you designed is correct, that the part layout is correct? That's why you make 1 or 2 or 10-piece prototypes?
Oh,
is that correct?
Yes, for sure. For sure, yeah, because the first one you make you'll probably miss a trace, or you'll miss a part or something that you need, or it'll just catch on fire.
Okay. Or you could just kind of burn the components and they just kind of smoke everywhere.
Right.
With that.
Yep. And then the magic smoke goes away. Yep.
Voltage regulator or something. Okay. Excellent.
Yep.
And then in terms of production, you were showing me a panel, and I'm seeing 4 pieces on a panel. So those go on a conveyor belt, and then the conveyor belt passes through a series of different machines. And like you explained, the first machine, it puts the solder paste on it. It uses a stencil, and it kind of squirts the plastic. It squirts the material, not plastic, the lead in a hole, right? And then all of those little holes, it goes to every little location on the circuit board. And then from there, it goes into what's called a pick and place machine, right? Can you tell me about the process of stencil, pick and place, oven? Like, how do those work, and how do I know what to use?
So yeah, and generally a pick and place line will have a stencil printer. It's called a stencil printer, a pick and place machine, and an oven. And sometimes they'll have an AOI before the oven and after the oven. So the first thing that happens, it'll go through the stencil printer. It's going to have like this squeegee to put the solder on all of the spots that need it using that stencil. Then the conveyor would move it forward. It would go into the pick and place where all of the little components would be placed. Then it would move on to the AOI, which is an artificial optical inspection, AOI. And basically would just check all the parts are in the right spot, there's nothing wrong, or it could make a box around it and have someone fix that, and then it would go into the oven, it would get baked, and then finally it would do another AOI to make sure all the solder baked properly and everything looks good, and then it would be off to depanel, so get it out of this panel, inspect everything, test everything, make sure it works, send it to the customer.
Assuming I wanted to make 10,000 pieces, do you go ahead and just run all 10,000 pieces and just call it a day? What's the process there?
No, you generally want to do a first article inspection. So maybe like the first panel. So we'll set up the machines, we'll do a panel, the best way to do it, right? Do a panel, break it out, test everything, follow some test procedure, or send it to the customer, make sure we get a quick yes or no or something's wrong. Because if we mess up something if we don't do a first article and we build 10,000, we have a lot of manual repair work to do if something is wrong. So we want to catch the mistake on the first article, not after we've run all of them. So generally we do one panel, and then as long as we got a thumbs up, then we can continue on. And then we don't really have to stop once we have tested the first article.
Fair enough. So you'll run the first panel, you'll do some testing. Can you speak to me about testing and programming? What's the difference, and why do we need those?
So testing is obviously just to make sure the board is functioning the right way, the correct way. And a lot of designers will put in test pads, like areas where we could use a multimeter or a special jig that we could build that, you just put it inside, you push down, you hit enter on your computer, and it just checks all the parts, make sure it works. That would be testing, and then programming would be like the final code that needed to be on the board. What the customer would provide that, or we would provide that, or whoever designed this would provide that, and then we would upload that using a computer. So that would be the code that runs on this particular device.
Very good. So how long, I don't recall, did you mention how long it takes to make circuit boards? You did, right?
Yeah, I did. I mean, it depends. Again, it depends on your fab house. Some people can do it really, really quickly, 24 hours, and they charge you a lot. And some people will do it in, 3 or 4 days or a week, a slower turnaround, but then you're not paying as much. So it's all about, quality and speed.
And then
Quality
you
and
have
price.
the circuit board, but then you have to put the parts on. So the assembly, how long does the assembly take?
The assembly doesn't take too long. It depends on the machines that your contract manufacturer has. Generally speaking, like it's the parts that take a long time to coordinate because there's so many parts and some might be on back order, so you're always waiting for all the components to show up because you can't run it unless every single component is ready to go. So that takes a little bit of time. And then once the machine is set up, depending again on the contract manufacturer, they can make hundreds to thousands per day. But that's just pick and placing, so getting these boards done, but you still have to test them. You still have to program them. That's all very manual. So that can take, days to weeks, depending on the quantities.
Okay, I feel good about this. So you're going from circuit board, you're doing circuit board assembly, you're getting it designed, prototyped, manufactured. I feel good. What else don't I know? What else should I be asking when I'm talking to a company and I'm trying to help, get help with the design or manufacturing? How do I get the cost down? I think that's probably a question I have.
Yeah. So there is, we talked about injection molding last week. There is some kind of DFM that you could do on a circuit board. One thing is you want to make sure that you use the same part as much as you can, right? So if there's a resistor that you're using that you could, and you have a different value on a different, area, well, maybe you could use 2 of those resistors and add up to the same value, and you could save the number of BOM entries that you have, because then you can buy more of that one part, and you'll get the scale, you'll get the discounted price because you're buying more. So that's definitely a way to get the price down. When you're doing your prototyping, your prototyper can tell you if there are problems with the board, like, hey, this thing's not soldering well, or this part keeps flipping up because the pad is too small or too big, or so those kinds of things can help with rework. The pad layout, the footprint design, all of those things can be really optimized to reduce cost and make sure that the board comes out of that machine and it's like you don't really need to do anything. It looks good and all it needs is program and it's out the door.
And when you're ordering the circuit board, the bare circuit board, does it cost extra to do any sort of like flying probe test or any sort of testing there to make sure that it's working?
Generally, they include all of the testing. When you order the PCB,
Okay.
they try to include all of that in the price because they need to do that so they can X out the ones that are bad.
And where does
So
all of this happen? You mentioned in the United States there are companies, obviously overseas
yeah,
there are
so there are
companies.
lots of companies, obviously, all around the world. In the U.S. they have lots of places that make them. Again, they do charge a lot more, but their quality is definitely very good. Most PCBs are made in China. I
Okay.
mean, most of these boards that we get are made in China, and even some of the U.S. companies will outsource to China.
So I'm afraid of my idea being copied. How do you prevent against that?
It's very difficult because once someone gets their hand on a PCB, I mean, in theory, they could reverse engineer it, right? So they could figure out how all the traces are, all the components. So a lot of times people will laser etch the part numbers off, so you can't see the parts. So it'll be really hard to figure out what it is unless you go into the trouble of X-raying and all that stuff. So you can laser etch it out. Secondly, the code, you can protect the code. Once you program it, you can lock it so that if I tried to read it back, you would just get all zeros. So you can protect the code. You can also, I know nowadays you can buy like authentication chips that only let's say you would buy 1,000 of them and you would send them to your manufacturer and say, here are my authentication chips. So you only send them 1,000, which means they can't make more. They need that chip to make it. So you can protect yourself in using authentication chips.
And then you and I, we have a terminology. We do the dumb stuff and the smart stuff. Can you talk to me about the smart stuff?
So this is the smart stuff, right?
Okay.
all of the code that goes in here is really where the value is. Again, if someone really wants to reverse engineer it, they can, right? They can spend a month and figure out what this is and how it all works. The code is generally where the smarts are, and it's a lot harder to do. There are ways to reverse engineer that too, but it's very hard.
And so
this is
typically
definitely
we would try to put the code on at our own location in the United States, right?
Yes. Yeah. So we'll probably, have this manufactured. If we need to make it in China, we'd make it in China, have it all shipped here and programmed, or we'd make sure that the code is with us and not with anybody else.
I feel good about that. So you can make custom shapes. You can do different type of technologies and chipsets. You can do different color circuit boards. Finding the different technologies is important. We can make a prototype, test and make sure that works. If it doesn't, we can kind of go back and do another prototype, put it through production. And we talked through, did we talk about pricing? Like what does it cost to make a circuit board assembly, or what makes circuit boards more expensive, like the chips or anything like that?
We did not. Obviously, the parts are the major cost, right? Some of these parts are like, you can spend between $3 to specialty parts are like hundreds of dollars, right? So a lot of the cost is in the parts, and the PCB also can be very complicated if you have like invisible traces inside and vias and stuff like that, like blind vias. You need special machines to make that, and multiple layers. So if you have more layers inside, that would also make it cost more. And then assembly-wise, depends on who you work with. They mostly charge per part. So every part that they put down, they're going to charge you some amount, plus some setup fees and all, the different setup and testing fees that come with that.
And then is there any waterproofing available?
Yeah, so you can conformally coat stuff. It's called conformal coating. You can buy, it's like a spray or a brush on, and they either spray it on or brush it on. Or I've seen baths as well, so you can dip it. But then you have to mask things off too. Sometimes you can't have conformal coating on certain sensors and stuff.
So you put tape and tape that off, right?
Yep, use masking tape.
Excellent. I feel good. What questions should I be asking that I might not be asking?
I know. I think you did a really good job. You definitely grilled me on some difficult questions. I don't think there's anything else. I think you did a good job.
Excellent. So would it be fair to conclude our video today?
Yeah, but first you got to tell them why you're over there and not in your normal hangout spot.
Oh, well, work vacation?
Work. Where are you at again?
I'm in Jewett, New York. I'm at some family's house, and I'm pretty much working in the basement all day in meetings and having fun here. We tried to shoot a little bit earlier. It's a little too windy outside, but I have a beautiful view of the mountain. But yeah, just work vacation.
Nice.
Glad to be shooting this video here, and I'm able to travel a little bit. And maybe in the future we could travel a little bit more and kind of show the outside world and kind of take our podcast and videos on the road.
Yeah, awesome. Yeah, I think that's good, Derek. We can conclude.
All right, guys. I really appreciate your time today watching this video and enjoying us. We are calling ourselves TechMates, and we're putting together these podcasts. The goal of these podcasts is more or less to educate you and to teach you the things that you don't know. And if there are things that you want us to take a look at or even talk about, feel free to leave a comment. Meanwhile, we really appreciate your time. Like and subscribe.
Thank you, guys. Take care. Don't forget to ring that bell, too. That'll help us a lot. Thank you.